Hey guys, this is video 11.7. Now we're going to take the last two videos and kind of put them all together here in one big long process. Okay, this is Net Ionic Equations. We're going to jump right in back to page 11 where we left off with the last video. And I'm just going to tell you guys right now, this is a process. This is something that is not super short. If you skip steps, you're going to be confused. This is something that you really want to watch this note video and then take probably a day in class and then at home, if you need more practice, to actually practice and master this. This is something that really is a huge deal because it's using those solubility rules. This is what we look at. This is what you're going to be checked on with your lab. So I'm going to know if you've done it. I'm not going to give you answers ahead of time when you do your Name That Precipitate lab. Excuse me. I will be checking your work when you turn it in. You guys are going to be on your own with those to see, hey, do I really know what's going on? And you also have a quiz on net ionic equations as well. So you really need to take the time to practice this and master it. Don't skip steps. So speaking of the steps, here are the steps that we need to go through. So the first step is we need to write a balanced equation. And notice, if you look at these, you have to predict products. So this is a review, something that we learned excuse me, earlier in the year. It was probably December-ish. It was unit 7, I believe, which was the reactions unit. So if you need to go back and rewatch a video, we're going to kind of review some of that here as well, but you need to do what you need to do so that you can master this. Step 2, once you have a balanced equation, you're going to use your solubility rules to determine the solubility, and you're going to break soluble compounds into ions. This was like what we did in video 11.6, okay, that dissolution of solids. Notice it says with your charges. It's all going to be very important. Insoluble compounds will remain together without any changes. Step 3, you're going to cancel out spectator ions. Think about this, okay? If you think of that term spectator, what do spectators do? You may think you're helping your team win when you're watching them, but you as a spectator are standing or sitting in the stands and you have absolutely no impact on that game. Okay, no matter how much you think you're going to cheer to, will them to victory. No, you're not. I'm sorry. It's only the players who are actually taking part. So we have these things called spectator ions in a reaction that are just there. They're watching the reaction take place, but they're not actually doing anything. So we're going to cancel those out. We don't care about those. We want to see the net, the final equation, the ones that are actually taking part in it. So this is that analogy I alluded to in the last video. When you have a paycheck, if you have one now or someday you will have a paycheck, when you take a look at it, you've got this thing called gross pay, and you have this thing called net pay. So gross pay, let's say, is something like $2,000, okay? But then you have things like taxes taken out. So there goes, 10% right there. Let's say, health insurance is another $100. Then you've got, this thing called FICA, which nobody really knows what it is, but it's gone. And you've got Medicare and Medicaid. So you've got all these things taken out. And when you do the math, you're left with something like, I got to do this math on the fly. 2, 3, like 400. So it's like $1,590. So you've just lost over $400 right there. A quarter of your paycheck is taken out. This is called your net pay. You do not have to write this down, by the way. This is just an example. Sorry if you did start writing it, but this is what's left over. So what we're trying to do with these net ionic equations is we're trying to take all this stuff out, these spectator ions, and get rid of those and see just what's left over. Okay, so that's the process that we're going to be going through. This, again, I cannot stress it enough, is a process. You've got to learn it. The only way you're going to learn it is by doing the practice. So those of you who decide, hey, I'm good, I don't need to even try the homework, well, you're going to be struggling on your quiz and on your test and when you see one of these on the region. So you've got to put that time in to really master that. Here we go. Let's jump in. So first things first, to predict products, split up our compounds. You should be good at that by now. Cations go with the other anions. So draw your arrows if this helps you to kind of say, okay, these are the ones that are going to match up. Remember, cation is always first when you write a new compound. Okay. The next step I would do for my balanced equation is write your charges. You're going to need to know the charges for the complete ionic equation and the net ionic anyway. So go find the charges of all these substances. Silver, if you look it up on your reference table, is a +1. Nitrate is a -1. Magnesium is a +2, and chlorine is a -1. Okay, now we're going to put these things together, and this is where this is you see the 3 lines. I've gone through and done that, kind of color coordinated it for you guys as well, so that you can kind of see the differences between them early on. Use the space that I give you. So here we go. We've got silver nitrate. Now it's not only good enough to just write that down. We have to know the solubility. So from here on out, the rest of the school year, you've got to consult your solubility rules. So flip back, find your reference table, go to table F, look for nitrate. Oh, look, nitrate is always soluble. Some of these substances that we use regularly, you're going to kind of remember them right away. So this is soluble, so I'm going to put my aqueous there. And then magnesium chloride. So notice the reactants, since I was given those, I'm good. I don't need to worry about how to, do my crisscross method or anything like that. Those are given to me. Look at halides. Okay, there's chlorine. There's no magnesium is not an exception, so it's going to be soluble as well. All right, so AQ. Now I've got to predict my products. This is where you've got to do the crisscross method to get your subscripts. So when silver pairs up with chlorine, all right, Ag is a +1, chlorine's a -1. Okay, so that's going to be AgCl. So we're going to go back. Now that I have a new compound, I've got to check my solubility rules. This is what we're using every single time. So chlorine, right here again, it is soluble. Is silver an exception? Yes, it is. So that means this is going to be solid. So you can see already how these kind of are tedious because you're checking your solubility rules every single time. And then my other one, Mg, if you remembered, nitrate did not have any exception. So anytime you see nitrate, it's always going to be aqueous. But I forgot to even show you this. I was taking it for granted. Do your crisscross method. Oh, we need 2 nitrates to balance that out. So now I've gone through, I've predicted my products, which again should be a review. We've learned this already. Now I've got to make sure I have a balanced equation. So if I look and take it, I need to put a 2 here, and I need a 2 there. Okay, so that's kind of step 1. We wrote our balanced equation. We also took kind of part of step 2 and figured that out. We used our solubility rules. We already figured out, okay, which ones are my aqueous and which ones are solid or insoluble. So now I'm going to write my complete ionic equation. So this is kind of the second part of step 2. We're going to break soluble compounds up. So anywhere you see aqueous, we're going to split those up like we did in the last video here, guys. So where you had those, this was solids that we did specifically, and we wrote the new equation, the products for that. We're going to break them up and keep them with whatever we see. So follow me. You'll see what I mean as we go through this. So I've got AgNO3. That's aqueous. We're going to split that up. So it's going to form 2 things. I've got 2 ions. I've got silver and I've got nitrate. Well, how many silvers? Notice, remember, this is again a review. This coefficient distributes out so that we have 2 silver ions. Put the charge with it because it's an ion. It's an aqueous solution. Plus, I have 2 nitrate ions. Where you have polyatomics, keep those parentheses. Notice what I put with everything so far. Each ion has a charge, and I put the state of matter. You have to have both. You have to include this charge, you have to include the state of matter, or else you're not going to get it right. And if you miss these little pieces, when you go to do your net ionic equation and you cancel out your spectator ions, if they're not exactly the same, it's going to be all messed up and you're not going to get the right answer. This is why it's tedious. This is why it takes practice. You've got to get in the habits that I'm showing you. All right, so that's our first one. We'll do the same thing. Can I split up the next one? Yes. This is aqueous, so I've got Mg with a 2+, aqueous state of matter, plus, now, here's the trick. How many chlorines do I actually have? I have 2. So that 2 now is going to become a coefficient, and I'm going to do the same with the rest, show my charge for chloride, and it's aqueous. Okay, so there's my reactants. I've split those up. Now I'm going to continue the same process for my products. Can I split silver chloride up? No, because it's a solid. Okay, only aqueous solutions can be split up. So I'm going to keep that, drop it down the same way. 2AgCl solid, and then I'm going to move on. Can I split this last one up? Yes, because it's aqueous. So it's going to be Mg2+, plus 2 nitrates. And see, this is another trick, guys, that I've learned from doing this for years and years. Why I did this right over here, where I went through and wrote all their charges down first, because I knew I was going to need them later on. If you write all your charges, figure them out first, those charges aren't going to change throughout your whole process. Okay, so write them down initially, and then you don't have to go back and flip through your reference packet, look at your periodic table, or look at your polyatomic ions list for those charges. Now, we're going to go to the next part. We're going to write our final equation, but we got to do to step 3 first, where we cancel out our spectators. So we're going to take the whole reaction. We're going to look at it all together. If you see the same number of ions on the reactant side as you do the product side, so here's my arrow. I'm going to kind of just draw a green line in there where it's separating, okay? In order to cancel them out, they have to be exactly the same on both sides. That means they're spectators. They haven't taken part in the reaction. So let's start with my first ion. I've got 2 silver plus aqueous. Do I see 2 silver plus aqueous over here? I do not, so I'm going to leave that. Move on to my next ion. Do I see 2 NO3 in parentheses minus aqueous? I do, so I'm going to cross that out. And you need to actually physically draw a line to cancel them out. Moving on to my next ion. Do I see Mg2 plus aqueous on the right? Yes, I do. Those get canceled out. Do I see 2 Cl minus aqueous over here? I do not. So if we take an inventory, this ion changed, this ion changed to form this guy. So the things we haven't crossed out, guys, we're going to drop down exactly the same way for our net ionic equation. So my final net ionic equation is going to be 2 silver ions, the aqueous state of matter, plus 2 chloride ions, aqueous state of matter, react together to form 2 moles of silver chloride solid. And there's my net ionic equation. Okay, so it's a long process. It is tedious. We're going to go through and we're going to do the next 2 problems together. I'm going to stop this video now because it's going to get too long and things may get messed up. So I want to I'll make a part 2 for it. But then we'll work through those same 2 problems a little bit faster than we did this last one. Okay, so go follow and find video or part 2 to 11.7.